we, I think, had just the last 4 problems left on this notes page from Friday. And we talked about breaking down our radicals. I've told you that I'm going to make you use one of my graphing calculators on this so that you're not using a calculator that's going to give you the answers. You have to be able to show me work, because it's really nice those ones that tell you the answer, but it doesn't work with variables. And if you don't understand the process, you're going to be confused when it comes to the variables. So make sure you know how to do that. We talked about the numbers, 72. We have to break that down into 2 numbers, one of which is a perfect square. So remember, perfect squares come when you take something to the second power. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Can everybody make this list on their paper if they needed to? You know where I'm getting those numbers. So you need one of those. These are my perfect squares. That would divide 72 evenly. And preferably we want the biggest one, right? Because if we don't get the biggest one, we have to break it down more than once. So what could I do? I always kind of start with the bigger numbers. I can't do 64, 49. Can you do 36, 72? Yeah. So 72 is 36 divided by 2. You could also do 8 and 9, but what happens if you have an 8? Break it down again, because it's still divisible by a perfect square. Okay, so the square root of 36 is 6. When you take the square root, that radical goes away. But I cannot do the square root of 2, so it's going to stay underneath. And I left a little space because now we need to come back and address all of these variables. So a square root is asking us how many groups of 2 can you make? So if I have 9 m's, how many groups of 2 can I make? Four. So that's an m to the 4th. When you bring it out, it's saying you have 4 groups of 2. But what else happens there? If you have 9 m's, four groups of 2, but there's one odd one out, so that stays underneath. That happens anytime you have an odd power. There'll be one left underneath. I took one of the 9 and left it here. The other 8 made 4 groups of 2. And then we do our n's. N has an even power, so should I have any leftovers? No. If you have 12, how many groups of 2 can you make?
6.
Okay, 12 divided by 2 is 6. All right, with my p's, I have 2 p's, so how many groups of 2 can I form? 1. And again, since the power was even, there were no leftovers. So my answer, 6 m to the 4th, n to the 6th p times the square root of n. So 22, I first have to break down 63. What perfect square would go into 63? No. So I can make that a 9 and a 7. Square root of 9 is 3. I can't do the square root of 7, so it stays under my radical. Right, from there, we look at our variables. Which ones are going to have variables left under the square root? We should have an x left, and we'll have a y left. And we know that because their powers are odd. If I have 5 x's, think about if you're doing laundry, and you have 5 socks, how many pairs do you make? You have 4 socks that can come out and make 2 pairs, and there is 1 left. Okay, 5 x's. If you need to, go out to the side and write it out. You can make 2 pairs, 1 left over. 25 y's. I would rather not write that one out, but if I have 25, how many groups of 2 can we make? If you do 25 divided by 2, it gives you 12 groups of 2, and it didn't come out evenly, so there was 1 left. If I have 14 z's, how many groups of 2 can that make? 14 divided by 2 is 7, and that works out evenly, so there's none left. So it's just dividing by 2. If it doesn't come out evenly, there's 1 left in there. Alright, 252. Need a perfect square that goes into 252. Everybody should be grabbing a calculator and trying to help me find one. 36 times 7 equals 252. The square root of 36 we can do is 6. I can't do the square root of 7, so it stays. Then we look at our variables. If we only have one x, you're doing laundry and you have one sock. Can you make a pair out of that? No, so it stays. If I have 2 y's, how many groups of 2 can we make? 1. Right. 2 divided by 2 is 1. If I look at my z's, I have 3 z's. It's odd, so I know there'll be a leftover. How many pairs can we make? 1. So it's 6yz times the square root of 7xz. Last one. 392. So perfect square that goes into 392. What do you get when you divide it by 49? So if I do that, the square root of 49 is 7. What do you notice about the square root of 8? We can break that down again. Okay, doesn't mean we're wrong, just means we didn't get the biggest perfect square, so we have to reduce again. The square root of 4 is 2 times the 7 we already have, so 2 times 7 is 14. 2 stays underneath. Alright, now my variables. If I have 2 a's, that can make 1 group of 2, no leftovers because it was even. If I have 2 b's, that can make 1 group of 2. Again, it's even, so no leftovers. 2 divided by 2 is just 1. But with my c's, if you do 3 divided by 2, you get a 1.5. So there's 1 that comes out and 1 that's left because it's an odd power. Rules that we had back when we were dealing with our exponents. Product rule. If you have 2 x's multiplied together, what do we do with their exponents? Add them. So that's x to the a plus b power. So for example, if I said x squared times x to the 7th, that becomes x to the 9th because it's saying you had 2 x's here and 7 here. Power rule. When they are written side by side like that, what do we do with those exponents? Multiply. So that's x to the a times b power. So if I had x squared, the entire thing to the 7th, that means I have x squared written 7 times. When you put those all together, you get 14 x's. Make sure you are filling in these rules. Study guides are usually completion grades. Easy points if you do it. And I'm doing part of it for you right now. Quotient rule. When things are divided, what do we do with our exponents? Subtract, yep. So that's x to the a minus b power. So if I said x to the 7th divided by x squared, you could write it out. 7 x's on top, 2 on the bottom. It reduces. 7 minus 2 is just 5. And the final exponent rule we had to worry about was when we had a negative. Negatives do what? Right. A negative exponent puts it on the bottom. And once you do that, the power becomes positive. So it's 1 over x to the a. So if I say x to the negative 3, that's 1 over x to the positive 3. Once you flip it, that exponent becomes positive. When we add and subtract, you combine like terms. But the exponents do not change. Okay, so if I said 3x squared y plus 4x squared y minus 8x squared y. These are all the same because they're all x squared y. When I put them together, it's still x squared y. You just combine the numbers in front. So 3 plus 4 minus 8 gives me negative 1, or just negative x squared y. All right.